So thanks for another fantastic con from Silvio and Kylie and all the organisers and volunteers. Running community events is extremely stressful, and they've pulled off another fantastic one this year. So what will Western Australia export when we can't dig anything more out of the ground? Could it be hackers? For 4 consecutive years, a volunteer team of pen testers, incident response specialists, software engineers, and other InfoSec professionals from around the Perth community have come together to build and run one of the largest capture the flag, or standalone capture the flag, or CTF competitions in Australia. Maybe it's the largest, it depends how you count, I don't know. So hi, my name is Sam, and I am the State Director for TrustWave in Perth. I look after WA and South Australia, but I've only been in that role officially for 10 days, so I'm better known as a principal pen tester for TrustWave Spider Labs, formerly from the Hivint side of things. I'm also the technical lead for WACTF. I build and look after the infrastructure and try my best to ease the integration pains for our challenge authors. Every year, a dozen plus hackers from Western Australia and a small number of interstate allies contribute their technical expertise to build challenges for WACTF. These were the technical contributors for our most recent event, WACTF 0x04, and it wouldn't have happened without them volunteering their time. More broadly, we've received financial support or other relevant contributions from several big players in the space, including AusCyber, Pentester Labs, Offensive Security, some universities and banks. WACTF 0x04 ran in December 2020, and we had more than 300 West Australia hackers compete in person for more than $15,000 in prizes. Perth was fortunate to skip most of COVID, so we supported multiple locations around the CBD for players to compete from, but we also had a number of pre-approved interstate and other remote players. West Australia is a big state, and we wanted WACTF to be as inclusive as possible to WA nationals. So at its fundamentals, WACTF aims to increase the cyber literacy and skills in the WA InfoSec community, facilitate new entrants to the field, whether that's from high school or university graduates through to people who are career transitioning, and to showcase the talent that we already have in the state to industries that are looking to hire InfoSec talent. Ultimately, WACTF aims to make WA hackers a cut above the rest. Or at least that's what I think. Maybe the real reason was just an excuse to hire an entire cinema for the awards ceremony and watch hackers on the big screen. We also eat several $1,000s of pizza each year, and we've even had Red Bull sponsor us, because hacking is an extreme sporting event. WACTF is a 2-day event with technical challenges built from real life. Many of us in this room would have played CTFs before, where to solve a challenge, you had to realize that some random string was encoded in some obscure way, and oh, what do you know, it's also been ROT13'd. I see limited value in those sorts of challenges. Last year's WACTF had 52 challenges split between web forensics, exploitation, crypto, IR, and MISC, and with the exception of the MISC challenges, every one of them were built or modeled off things that the challenge author had seen in the real world. In its humble beginnings, WACTF started as a set of shared Docker containers running on a single host. We also had a syslogger and a jump box for administration. This was the layout for the first 2 WACTFs. With so many challenge authors, we needed to make sure we could support their contributions without needing them to learn a bunch of new tools and ensure that if it worked on their machine, it would probably work in prod. So Docker was a logical choice here, and we still use it to this day. Here's a Docker file from our last year's WACTF. All of our containers must be built from maintained minimal attack surface base images, such as Alpine Linux or Docker Scratch. They also mustn't run the challenge binary as root, and we do not allow privileged containers. Privileged containers are often the first thing that gets mentioned when talking about Docker security. They have most of their isolation techniques disabled or severely weakened, and they grant the container full access to devices on the host without any capability limitations. Capability limitations are a key strategy used by containers to reduce their attack surface and hence the ability for an attacker to escape out of the container. Root inside of the container isn't the same as root on the host. Linux divides the privileges traditionally associated with the root user into these distinct units that are known as capabilities that can be independently turned on and off. Docker containers, by default, already have a reduced set of Linux capabilities, assuming they're not privileged containers. So if you find yourself in a container as part of an engagement or another CTF, you should check to see if you're in a privileged container. You can do this by trying to run a command that requires a capability not normally given to Docker containers, such as the ip-link add command, which requires netadmin capabilities. Or if you have it, the capsh command will print all the capabilities available to your container, even if you're not root. Escaping privileged containers is outside the scope of this presentation, but if this is new to you, I highly recommend you check out Frenchie and Meyer's talk from BSides San Fran last year called Checking Your -- Privileged Container. We also use Docker Compose for authors to specify which ports they need exposed for their challenge to run, and also to set resource constraints on the containers. Docker Compose is a simple tool that moves the configurations that you would normally have specified in the command line when spinning up one or several Docker containers into a YAML configuration file. We'll come back to Docker Compose later on. The limitations of this early setup were clear. Shared containers greatly reduce the types of challenges you can have without the player being in a position where they can tamper or break the challenge for other competitors. It meant that having shellable challenges and many sorts of privest challenges would be extremely difficult. So without wanting to break the challenge author's Docker and Docker Compose workflow that they're familiar with, but also wanting WACTF to grow up and support unique environments per team, I decided to follow what everyone else seemed to be doing at the time and use the container orchestration platform, Kubernetes. And with that, our infrastructure now looks a bit more like this. To break this down a bit, we'll start at the top left with the challenge authors. Each challenge author has access to their own private GitHub repository inside the WACTF GitHub organization. This is where they push their challenge code, Docker files, Docker Compose segment, and their documentation. The private repo setup prevents the challenge authors from seeing challenges that they didn't develop. As much as I trust all of the WACTF contributors, with more than $15,000 in prizes each year, we have to put in a bit of effort to avoid cheating. The challenges are then QA'd and merged into a production repo, which is pulled in by our private Docker image repository, where they're built into static images. I refer to this process as baking the containers. I don't think that's canon, but it makes sense to me. We're taking our Docker files and the source code, and we're baking them into an image file. We also use a project called compose.io to convert our Docker Compose file into something that Kubernetes will understand, which are deployments and services. That's then all pulled into the Kubernetes cluster itself, which we have previously run on Google's Kubernetes engine, or GKE, and it's then replicated for the number of teams that we have. So this is the model we've used for the past 2 years. From the player's side, each team has a unique namespace within Kubernetes containing all of their challenge pods. Pods are Kubernetes speak for containers. Technically, one pod can contain many containers, but in WACTF it's one-to-one. Each team has an OpenVPN pod, which is the only internet-exposed container. At the start of the game, players are able to download their team's specific configuration and connect into their own internal game network, segmented from any other team, and it even has internal DNS for them. Last year, WACTF kept more than 3,600 containers alive across 190 namespaces, consuming 1.28 terahertz of compute and 300 gigabytes of RAM, and it cost us $600 a day, which I think is pretty impressive. In each team's namespace, there's also a shell box, which can be SSH2 for the players to receive reverse shells and other callbacks from challenges. The shell box has several familiar tools installed on it, including Bash, curl, wget, vim, and nano. And I can understand if this setup raises an eyebrow. There are not many environments where you willingly let hundreds of hackers have fully interactive shells within them. We built this environment with the expectation it would be hacked, just hopefully in the ways that we were expecting. If you're a defender who uses Kubernetes yourself, ask yourself what happens when your containers are shelled, when the attacker has persistence in a Kubernetes namespace. What then? Well, for us, and likely you too, you're going to be concerned with the attacker doing one of two things. Either escaping the container security boundary, so if a player is able to execute commands on the Docker host, which is the Kubernetes node that they're residing on, from within inside a container, that would likely be game ending for us, or an attacker moving laterally or escalating their privileges within the environment, so living off the land. if a player is able to access resources from other namespaces, interact with Kubernetes itself, or the cloud services residing on, that will also be game-ending. So let's take a look at number 1 first. As I mentioned before, we use Docker Compose to configure our containers. Here's the segment of our Docker Compose file for the shellbox. You can see here we set container resource constraints. So this is saying that at peak, for any given team's shellbox, it can consume 5% of a single CPU core and 60 megabytes of RAM. Not only do resource constraints deter any resource consumption denial of service attacks, but they also allow us to quickly calculate the total resource consumption required for the cluster to help us make costing estimations. You can see that we also drop all the Linux capabilities from the container and then selectively add the ones that we know that are specifically required for the container and the programs installed on it to run. We do this for shellable containers, but since the overhead for doing this is pretty high, for other challenges, we leave most of the capabilities alone, and the Docker Compose segment looks more like this. Due to a legacy compatibility issue with Docker containers in Kubernetes, containers are given an extra capability, net raw, by default, which allows them to use raw and packet sockets. What that means practically is that containers can DNS spoof each other and intercept traffic that's destined for one another. Obviously, that's far from ideal, so we drop that capability from all of our containers. This attack depends on the cluster using a networking stack that supports ARP spoofing, but that's actually pretty common, so I'd recommend both attackers and defenders check out the Aquasec blog on the topic and race each other. You've probably heard this saying before, because it's almost guaranteed to be brought up whenever anyone talks about container security. Containers aren't a security boundary. But let's be honest, that's a little bit confusing, because the name kind of suggests that they'd be good at containing things. But that's only the beginning of confusing container stuff. This is a diagram that roughly outlines the container ecosystem today, and there's already too much shit in it to understand. There's a good chance that what you think Docker does is actually what 2 other projects that you've never even heard of do, Containerd and runC. See, Docker is only responsible for providing the nice experience you get when working with containers. It helps you run Docker files, parse Docker files, run containers from the internet, and that's about it. It provides you a CLI for interacting with those things, and that's nice. Containerd is the API that sits between Docker and the runtime. It's responsible for managing the lifecycle of the containers. And then lastly, you have the runtime. By default, Docker uses runC. They were the original developers of it, and this is where the magic happens. The runC container runtime is responsible for providing the sandbox that runs your workload. It's what's known as an OS container, or a lightweight virtualization platform, which makes heavy use of existing security controls available in Linux, such as namespaces, seccomp, AppArmor, etc., to do this. So when you hear someone talking about Docker container escape vulnerabilities, they're much more likely referring to runC escape vulnerabilities. runC is the software that's in charge of containing the processes running inside your container, and it's only as good as the containment features available to the host kernel. Are you feeling a little bit like this right now? Maybe you're wondering, why does this even matter? Well, I'm not suggesting that runC is poorly developed, because it's definitely not, but how it performs containment has limitations, and there are other runtimes that address those. So we changed our runtime to gvisor. It's a security-focused container runtime that's designed to be a drop-in replacement for runC. It's built by Google, and it aims to be an emulated Linux kernel that sits on top of the host kernel and operates in user space. You can think of it like a little mini kernel that operates on top to provide a defense in depth step. It's not quite a virtual machine, but perhaps it's the next best thing. There are several other container runtime technologies built for security in the ecosystem. Kata containers and Firecracker VMs, which are just to the left of gvisor there, are probably the most popular. These are marketed as micro VMs that behave like containers within Docker and Kubernetes, but provide the separation and segmentation of real virtual machines. That's definitely an area that we're looking to move towards in the future. So before we get too far ahead of ourselves, I wanted to recap of what we've looked at so far. So we've accepted that hackers are going to have persistent access to at least one of our containers, and we've taken steps to reduce the attack surface of the containers themselves by using minified images and not running vulnerable binaries as root. We've further hardened our particularly sensitive containers by reducing their capabilities, and we've implemented a security-focused container runtime to further mitigate against container escape vulnerabilities. But what about the other scenario, attackers that are looking to live off the land within the Kubernetes environment? Well, there's three main ways an attacker is going to try and do this: abusing inadequate firewalling or accessing internal resources, leveraging service account tokens, and leveraging Kubernetes secrets. Kubernetes has the concept of network policies that are used to create rules and control the flow of data within the environment. We use these to build the team environments. This is a policy that's applied to each namespace to segment teams from one another. As you can see, they very quickly get hard to read and digest. Thankfully, there are some good tools to help visualize them. So this is the same policy now, but visualized. It shows the team namespace in the middle and all ingress traffic on the left and egress traffic on the right. From the ingress side, we can see that only traffic from pods in the same namespace is permitted, with all other ingress traffic, whether it's outside the cluster or inside the cluster, being denied. From the egress side, we can see the policy disallows any connections to pods outside the namespace, with the exception of the Kubernetes DNS pods that are shared by all teams and load balanced in a separate namespace. It's not shown in this image, but we only allow UDP port 53 to these pods to facilitate DNS and nothing else. We have another policy specifically for the OpenVPN pod to punch through this to the internet, but again, only on the UDP port that is required. This policy also does one other massively important thing, and that's to prevent the player from interacting with the Kubernetes API or any cloud metadata APIs. These are the holy grails of APIs if you find yourself in a position to interact with them. Each cloud service provider has an internal API that can be used by resources within the tenancy to access various configuration information. They're mostly unauthenticated APIs and sometimes contain secrets or other information that can be leveraged by an attacker. And then the Kubernetes API is the same one that's used by kube control, which is the kubectl command to administer most of the cluster's functionality. It can create pods, remove them, modify them, change firewall rules, execute code within existing pods, drop shells into pods, you name it, this API can do it. There's a great bug bounty report on HackerOne of the tester using a server-side request forgery vuln to interact with the Google Cloud Metadata API and then using it to obtain root access to a portion of Shopify. To do that, they use the kubeenv Google Cloud API. This is one of the more lucrative APIs for Kubernetes clusters hosted in GKE. It's enabled by default and can only be disabled via the command line on creation of the cluster. This kubeenv API returns a significant amount of information about the Kubernetes cluster, including a client certificate and enough information for you to authenticate to the Kubernetes cluster using that other API, the Kubernetes API. The severity of this will depend on specific configuration, but at least for the near future, this will get you within a couple of degrees of a complete cluster own. You can see here the kubectl command using the extracted certificates from the Google API to interact with the Kubernetes cluster. The kube-let-me-in project is a much easier way to abuse this API, and it has support for all the major cloud-hosted Kubernetes clusters. So the second API that's available by default to resources in clusters is the Kubernetes API. As I mentioned before, this is the same API that's used for management of the cluster, so it's often exposed externally too, and getting privileged access to it really is game over. It has a DNS entry internally, so from any container you can easily find it at kubernetes.default.service. Thank goodness for the defenders, it's an authenticated API. Kubernetes supports a couple of authentication methods, but at minimum, it requires a JWT for all sensitive API calls, regardless of whether they're internal or external to the cluster. And thank goodness for the attackers, there's a world-readable JWT mounted to every container. It's always in the same predictable location too. So with a shell, a local file disclosure, or even some SSRF fonts, you can very easily begin using this API with these credentials. BSides Sanfran CTF found this out the hard way in 2017, as this was the vector that resulted in compromise of their CTF, and Down Under CTF almost found this out too in 2020. Thankfully, these days, the JWT that's mounted to pods by default has a reduced set of capabilities. So it maybe wouldn't have been game-ending for them, but definitely one step too close for my likings. I'm told a great CTF otherwise, though. So WACTF makes use of another policy to ensure that these tokens are not automatically mounted to our pods. Having your pod interact with the Kubernetes API or any cloud metadata APIs would have been something your team has very deliberately done. In many cases, there's no reason why you'd want your pods to communicate with these APIs, and so firewalling them away and removing the auto-mounted service account token may be quick wins for you. But that's not even the most bizarre secrets management thing that Kubernetes does. Kubernetes secrets are a way to expose sensitive data to pods. The documentation states that this is a recommended way for exposing things such as passwords, OAuth tokens, and SSH keys to your pods, and is safer and more flexible than baking that stuff into the container image itself. They're either exposed to the pods via environment variables or similar to the service account tokens mounted to a folder inside the container. Calling them secrets, though, is a bit of a stretch because by default they're just unencrypted base64 encoded strings, which is comical enough to be a CTF challenge in itself. Hint, hint for the next WACTF perhaps. So hunting for secrets and running the env command if you've landed a shell in a Kubernetes environment could be a quick win for you attackers. So to recap again, we now know that making use of strong network policies, no service account tokens, and no Kubernetes secrets by default are some good strategies to contain an attacker once they're inside your Kubernetes environment. So that's really all I wanted to talk about today. We will probably, maybe, I don't know, run another WACTF this year. I'm interested in opening WACTF to more interstate players, but we'll tread carefully on that one to ensure that WACTF stays closely aligned to its goals. We have always had the ability to reboot pods and push updates to pods if we've needed to, like mid-CTF, but allowing the players themselves to reboot a pod if they feel like they need to, sort of like OSCP style, would be really good. We had AD challenges back in WACTF 0x03 in 2019, but they were an absolute nightmare to get working, and they only came through in the sort of 11th hour, so no one was keen to try them again for last year. But it's a great CTF area, and so I'd love to bring those back as well. And WACTF has always been a 9 to 5, Saturday to Sunday thing, and I'm not a fan of big 48-hour competitions and stuff like that, but given that a lot of people work on the weekends as well, it would be nice to extend the hours a little bit, maybe go from 9 a.m. to 9 p.m. or something, so that if people work a shift, they can still jump in and have a bit of fun. And so with that, I'll wrap up. I think as my closing point, I hear a lot of people say that Kubernetes is hard to learn or it's hard to use, but I actually disagree with that. I think that anyone in this room could use Kubernetes tomorrow and start deploying workloads on it. But the more you learn about Kubernetes, the more you realize just how easily your cluster could be owned. And I think that's the hard part about Kubernetes, is building and maintaining secure clusters. So thank you very much. My name is Sam. I'm the State Director for TrustWave in Western Australia and South Australia, but I live in Perth. You can reach me on Twitter or LinkedIn if you're that way inclined. Not to shill my company too hard, but we do all things cybersecurity, so if you do run a Kubernetes cluster and you're interested in making sure it's secure, I can probably help you with that. Thank you. Yeah, very good question. We actually haven't yet, touch wood. Yeah, so we haven't had any container escapes or any sort of major problems like that. We've had a couple of challenges that didn't work as intended, and we had to push updates to them. Mostly our problems have come from the cloud service providers that have been hosting our clusters. So we used to run on DigitalOcean, but unfortunately we hit a scaling issue on them, and the DigitalOcean dashboard was throwing 500 errors the night before the game, and support wasn't answering, and that was scary. So we don't use DigitalOcean anymore. Yeah, very good question. So the answer is possibly. I'm not too sure if they can DNS spoof across namespaces, though. And if they could DNS spoof across namespaces, that would be a much more severe problem. You could cause denial of service issues with other players' pods. And so I just would much rather play it safe and drop that capability since that we're never going to need it, rather than tempt fate.
Yeah, good answer. Another question, is there any specific reason you chose to go with Google Kubernetes versus Kubernetes on AWS, for example?
Because Google gave us money.
And another question, the questions are coming in now. Do you find it hard to keep up to date with Kubernetes changes, or is that mostly handled by hosted Kubernetes?
Yeah, so it's definitely one of the pluses or positives for using a hosted Kubernetes cluster like GKE is that a lot of that, for the most part, gets shielded. You're shielded from that. So, but yes, it is challenging, and I'm sure as we ramp up to do WACTF 0x05 this year, I will have to spend dozens of hours reading what has happened in the Kubernetes landscape over the last 12 months, and I'm sure there's been tons of things. Like, through this presentation, I really only touched on some of the bigger ticket items for Kubernetes security, but there's so much more. Pod security policies I didn't mention at all. Security of kubelet itself, which is the process that Kubernetes runs on the node to manage the containers on that node. There's a whole raft of security stuff that you have to be wary of with that. Thankfully, like, GKE does do a lot of that stuff for us.
A few more questions. One question by GT, noting the historical advice against containers in containers, will WACTF be able to host challenges targeting Kubernetes itself with the current infrastructure?
Yeah, not with the current infrastructure, but it is definitely an interesting CTF avenue to explore, and I would like to explore it. But I think we would be. It could go south, turn south very quickly if we tried to have people hacking the Kubernetes infrastructure that was also hosting all of the other pods for other players.
And a few more questions still. Given the secrecy about challenges and their solutions and so forth, how do you handle testing of the challenges?
So the expectation is that all of our challenge authors should do all their local testing of their challenge so that they feel fairly confident that someone with some amount of technical ability could read their documentation and solve the challenge itself. So we have, every year there's a couple of challenges that don't integrate kindly, and it's not necessarily the challenge author's fault, it's just Kubernetes nonsense. So when those, once the challenges are submitted, we have a much smaller set of quality assurance personnel, just 3 or 4 people who will go through and QA those challenges themselves on their local machine, and then I will help them integrate that into a little development Kubernetes cluster that we run for a couple of months before the conference, before the event rather, and so we'll do a bit of integration testing there. We'll make sure that the documentation still works and can still solve the challenge, and yeah, but there's always issues, but thankfully most of the kinks are ironed out by the time of the competition.
And we'll have one more question. What are some of your favourite past WACTF challenges?
Oh, gosh, that is a fantastic question. There are so many. That's such a hard one. So the Active Directory challenges were really, really cool because that's something that not a huge number of CTF challenges, CTF competitions around the place have. So it was really cool watching people learn like Kerber roasting for the first time and jumping onto getting like local admin on boxes. Like, that was very cool. We've had some fantastic web challenges as well where the developer or the challenge author has put a lot of effort into making it a working and very realistic web application as well. It really takes a lot of enumeration to find the entry point that you're looking for. And I love those. I love challenges that when you load up, it looks like it looks really real and it's not just like 2 HTML text boxes, log in here, nerd,
Well, great answers to all of those questions. Let's give Sam one more round of applause.